Okay, direction fields. So let's go back to just thinking about this equation. We have y prime is equal to x plus y. Now let's try to attempt to integrate this to find out what actually y is, and you'll see that. Right, so let's bring the y together and you get this. Y prime minus y is equal to x. Okay. This is actually, we have to replace with dy over dx. So you have to try to bring the x with x together and y's with y's. And look, if I multiply both sides by dx, right, I can't seem to separate the dx with the y. So this is not a very straightforward way for us to, there isn't a straightforward way for us to find the exact function of x. Okay, so instead what we're going to do is we're going to create a direction field. Okay, so it's a map of how the slope will generally behave. Okay, so let's plot a few to show you what I mean. Y prime is equal to x plus y. Okay, so that's the way we're going to plot. The way I'm going to plot this is I'm going to fix the x and vary the y. So if x is equal to 0, okay, x is equal to 0, and y is equal to 0, the slope is 0. So the slope here will be 0. It's like horizontal. And when x is equal to 0 and y is equal to 1, the slope becomes like 1, right? So at 1, it's 1. And when it's 2, it's going to be 2, a little bit more steeper. At 3, right, the slope is going to be 3, even more steeper, right? Even more steeper and steeper, right? So when it's 0, negative 1, the slope is going to be negative 1. It goes down this way. Then negative 2, a little bit steeper, a little bit even more steeper, even more steeper. Okay, so that's the direction fields on the y-axis. So let's see what happens if I change the x to 1. When you plug in 1, 0, the slope starts from 1, right? And then it'll go to 2, a little bit steeper, right? A little bit more steeper, even more steeper. So it's exactly, the slope is exactly 1 more than the one on the left. So it's a little bit more steeper, like as it goes up. Okay, here it's 1, and then it's going to be 0. Okay, 0. So in fact, okay, so there's a 0 here and there's a 0 here. You know, if you continue this pattern, 1, and if you, at 2, there's going to be a 0 here. At 3, there's going to be 0 here, right, and so on. Right, there's going to be 0 going diagonally up like this too. Okay, and the pattern is the same. So it starts from 0 and goes, 1, 2, 3 up, 1, 2, 3, 4 up, right? So here it starts from 0 from there. Here it starts from 0 from there, and you get slope 1 here, 2 here, right? And just gets steeper, a little bit steeper than the slope on the left. Okay. So again, the slope is 0. It's 1, not as steep as the one on to the right, right? And then it gets. So actually, look. Here's slope 0, it goes diagonally across, right? Slope 1 will also go diagonally across. So maybe that's a better way to see this. And slope 2 is also going diagonally across. Right? So it's 2, 2, 2, 2, 2. And slope 3, you can see my point. And you see what I'm doing, right? So if you plot this, so after plotting it, and here's a computer-generated version, right? So look how we have a diagonal row of slope of 0, right? That passes through the origin, right? And then this is all slope of 1, right? And then it's all slope of 2, and so on. Now they tell us that the graph passes, the function passes through 0, 1. Okay, so 0, 1. 0, 1 will be right here. Okay, so it passes through there. And the slope there will be 1. Okay. Okay, so you have to try to follow your slope field, right? If you pass through there, it will go up like this. Right. And from here, it's flattened out here, and the slope actually gets not as steep. Okay, so that will be a graph of this function here. That's expressed as a differential equation, which we cannot directly find directly find the actual explicit equation of the function.